Today we're going to cover 5.1. The midsegment and coordinate proof. Our objective is to use properties of midsegments and write coordinate proofs. A midsegment of a triangle is a segment that connects the midpoints of two sides of a triangle. So we've got D and E. I know those are midpoints because of these tick marks. Those two tick marks show that D is the midpoint. The tick marks on the other side show that E is a midpoint. When I connect D and E, then I have a midsegment. The midsegment doesn't have to be horizontal. If I found the midpoint of side AC, say it's here, and I connected E to that, that would be a midsegment. Let's call that F. DEF would be a midsegment, and EF would also be midsegments. So there are three midsegments in each triangle. The midsegment theorem says the segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as that side. In this picture, DE would be parallel to AC because DE is the midsegment, and DE's length would be half of AC's length. Always. The midsegment is half the length of the segment it is parallel to in the triangle. Let's look at some applications of this. UT is a midsegment of triangle PQR. Find X. What would X be? It's half the length of what? It's 5. Yeah, how'd you get that? What's the half of? PQ. That's line PQ. Yeah, it's half. This UT is a midsegment. This is the line it's parallel to, so it's half of it. So UT equals 5. Half of PQ. This example is not in your notes, I guess. The next one is. In this example, in the diagram, ST and TU are midsegments of the triangle. ST is 8. QP is 10. We've got to find PR and TU. What would PR be? Bobby. Right. What is ST half of? ST, this line is half of PR. So if ST is 8, PR equals 2 times 8 equals 16. So PR is 16. Two times 8 equals 16. And UT would be, Michaela?
4.
No, it's not half of ST. Allie?
5.
Yeah, it's high, 5. It's half of PQ. Everybody have it? All right. So here we have a truss. You probably have seen trusses probably on the highway, on trucks, or near, or when they're constructing a home. It's the load-bearing structure of a roof. All right. So we have in this example a truss, and it's marked up with these tick marks to show congruent segments. And we're going to figure out some different lengths in this truss. So AG in the truss, this entire length, that is 24 feet. AJ is 15, as is GJ. HB and LF are both 3. We've got to find CD. What is CD and why? Use the markings in the figure. What would CD be? Michaela.
7.5.
It's not 7.5. Ellen? Ryan?
24.
How'd you get that, Ryan?
So I took 24 divided by 2, and the 3 triangles, the lower triangles, are all congruent to each other, so I divided it by 3. Divided 12 by
3 triangles are congruent to each other. Well, I mean, I think you got you're on the right thinking. It's just I think an easier way to describe that is we've got these markings, right? We've got each one of these segments is the same length that I just marked, right? There's 6 of them. So the entire length is 24. If it's divided into 6 equal segments, we divide 24 by 6, and that would mean CD is 4, right? What would CI be? Any ideas on CI? You're going to use this HB being 3. That's going to help you find CI. Yes. It's not 5. Okay, take this triangle right here. Right? We take just that triangle. What is HB in that triangle? 3, and what is it? What would we call it though? What would we define it as? It's a mid-segment, right? HB is a mid-segment, and it's parallel to IC. So if HB is 3, what's IC? It's not 3. 6, right. This segment is half of the base. So it's 6. So IC would be 6. Can we conclude that HB, IC, JD, KE, and LF are all parallel to one another? Yes, we can, because they're all mid-segments, right? And also because of these right angles. They're all at right angles to AG. So you can conclude that they are parallel to one another. Their corresponding angles are congruent. Coordinate proof. A coordinate proof involves placing geometric figures in a coordinate plane. Variables can represent the coordinates of a figure. The results are true for all figures of that type. So an example of a coordinate plane, a figure in a coordinate plane could be an isosceles triangle. Now we want to place the triangle in the coordinate plane in a convenient way so that we can refer to different segments. To do that, you always put one vertex at 0, 0, and then you try to make another one of the sides of your shape either along the x-axis or y-axis. What that looks like is this. So we have, this is an isosceles triangle, right? So we have 0, 0 is this point. We put this side along the x-axis. And we said its length is 2m. If that's isosceles, we know this point's halfway between 0 and 2m, right? So it would just be m. And then they call the height m as well. It doesn't have to be m, but if it's equilateral, it doesn't have to be m, but they call the height m. But anyways, so this is 2m, halfway would be m, and then they gave the other point m. This value, the y value could be any variable, any number, because it's isosceles. Does everybody get the idea of graphing a figure in a coordinate plane? All right. Everybody has it? All right. Now we're going to do constructions.